Welcome to the last unit on the various neuro diseases. We're going to start by talking about Parkinson's and Alzheimer's disease today. So these are both degenerative diseases, which generally refers to a class of diseases in which degeneration of the nervous system is sort of the central uh, reason behind its development. Degenerative diseases are chronic neurological conditions associated with progressive loss of neurons. These can occur without any evidence of inflammation or cellular necrosis, death resulting from insult or a concussion. Some examples include Parkinson's and Alzheimer's, the two we will talk about today. Parkinson's disease is the second most common neurodegenerative disease. It has a mean age of onset of 57 years and affects about 1 to 2% of the population over 60 years of age. The cause or etiology is unknown. The disease progression is highly variable. It can start at a young age or an old age, and it can be caused by some sort of early onset factor. There's a little brief video clip about
Back
raising
to the
awareness.
Future was a film that helped define the 1980s and made Michael J. Fox a star. More hit movies followed, as did a string of awards for his TV series like Spin City. Now, though, his future's increasingly defined by Parkinson's disease.
As soon as I wake up, I can't go back to sleep. I mean, it starts going. So I would say that's the toughest part in the morning is to kind of go, well, I'm up whether I like it or not, I'm up now. And the other thing that happens to me in the morning, first thing is I get that dystonia, which is kind of cramping, and it can be very extreme.
In a rare interview on ABC, he spoke about the new challenges from something as simple as using a toothbrush.
Because I have to put the brush down on the countertop, hold it flat, and get the bristles on, because if I hold it, I'll miss it. It's a moving target. But then once I get all loaded up, then I just kind of bring it up to my mouth and then just let it go.
Remarkably, he also revealed that ice skating appears to temporarily block his symptoms, but only while he keeps moving. There's no cure for Parkinson's, but Michael J. Fox has been fighting to change that. He's gone from actor to activist, campaigning for politicians backing stem cell research, which might offer hope to Parkinson's sufferers. Millions have seen the powerful TV campaign he made a few years ago.
They say all politics is local, but it's not always the case. What you do in Missouri matters to millions of Americans. Americans like me.
Michael J. Fox returns to ABC with an...
Back to the
So, Michael J. Fox has been a common, a very prominent figure in the Parkinson's field for some time. Common spokesman for various foundations, in addition to a wealthy benefactor that has spent a lot of money on promoting awareness involving the disorder. But the number of new cases of Parkinson's disease increases as a function of age, with the most occurring, after the age of 70. Michael J. Fox in particular would be an example of very early onset Parkinson's disease. In fact, there's been some speculation, involving, drug use and how that could have played a role in Michael J. Fox's case. In particular, we'll learn about another drug called MPTP that is still used as a model of Parkinson's disease because it can lead to the death of dopamine neurons. And this was sold as a synthetic form of heroin around the time that Michael J. Fox was, producing movies and was at sort of the height of, the Playboy era of Hollywood and his role in it, and sort of like the Rat Pack and these sorts of ideas, like the fun sort of party scene of Hollywood. It is possible that there was, tainted drugs around. It is also, there's no clear evidence that did play a role in Michael J. Fox's case. So, this is nothing but a speculative rumor. But when we think of things that can cause Parkinson's disease, remember it is unknown. And while there are genes that are likely playing a role, there are certain things and environmental influences that might turn on these genes, including tainted drugs of abuse. So, this is just to show similarly that, in addition to the age of first onset, the prevalence of Parkinson's disease increases as you age and really begins to plateau as you're quite older. Again, with ages that are quite older than Michael J. Fox, especially when he first developed the disorder. There might be less prevalence of Parkinson's disease in China and in other Asian countries. This could be more of a Caucasian disorder, but it is in no ways limited to Caucasian populations. The prevalence rates in men are also slightly higher than in women for reasons that are unknown. There has been a role for estrogen that has been debated. It's also possible that at least historically, there have been eras in which men maybe have been exposed to more environmental toxins. But these are all, again, speculative things. The idea of estrogen having protective properties across a many wide array of disorders is something that has gained great interest. Now, of course, the issue of menopause becomes an issue here. Estrogen regulation and the role that might have on neuro disease or preventing neurodegeneration is one that you will hear quite a bit about, I think, as we are growing, older and more aware of the importance of hormones and sex differences in how we approach medicine. So, something to be aware of. There are many symptoms of Parkinson's disease. The main four can be referred to as TRAP, tremor, rigidity, akinesia, and postural instability. There are several clinical features of Parkinson's disease. The resting tremor is, what Michael J. Fox was referring to. He first wakes up in the morning. You're greeted with this. It's also, the most common first symptom, usually asymmetric and most evident in one hand when the arm is at rest. Bradykinesia is difficulty with daily activities such as writing, shaving, using a knife and fork, opening buttons, decreasing blinking, masked faces, showed chewing and swallowing, similar to Michael J. Fox's description of the toothbrush. And then there's rigidity. Muscle tone is increased in both flexor and extensor muscles, providing a constant resistance to passive movement of the joints. You also see stooped posture and flexed knees and elbows. There are also a variety of non-motor symptoms, including changes in mood, including increased depression, changes in mental processing in general is changed. You can have sensory problems as well, including vision processes. REM sleep disturbances are common. There can be impaired proprioception, the ability to sense something touching the skin. There can be increased oily skin, weight loss, incontinence, constipation, or drooling. Age is the most important risk factor. This goes up tremendously once you increase past the age of 70. There's also a positive familiar history, which can be a risk factor, suggesting that there is some genetic component. There also seems to be a risk of being increased risk if you are male. Environmental exposure from things like herbicide, pesticide, heavy metals, well water, farming, living in a rural area where you could be exposed to these factors, or being exposed to a mill where you might be exposed to these factors, or in certain steel alloy industries, various environmental vocational work factors could play a role here. There also seems to be some association with race. One, I think fair criticism could be whether or not we focus so much on Parkinson's disease because of the race that it is most prominent in. Chew on that one for a little bit. Why are we spending so much time on Parkinson's disease? Who is it most prominent in? There are also several life experiences that could play a role involving trauma that could bring out symptoms. In general, I begin many neuro disorders. We are beginning to think of these things not in terms of whether or not they're necessarily genetic or environmentally induced, but the way that all of these things seem to work is that the genetic risk factors can be turned on by life experiences and environmental exposure. There is an interesting inverse relationship between cigarette smoking and caffeine intake. Cigarettes in particular have gained quite a bit of attention. I worked across the street from a spin-off company from Camel Cigarettes that looked into developmental treatments for Alzheimer's disease, which we'll talk about a little bit here in a minute. There is, clearly a confound here that if you don't live long enough to get Parkinson's or Alzheimer's disease, you won't develop it. And if you die from lung cancer, that sort of is one mitigating factor. You get rid of that, the age factor. But I don't think getting rid of the age factors is really the goal here. But there is something to this idea, and the idea is that nicotinic receptor stimulation might trigger pathways in the brain in sort of the same way that a crossword puzzle might. There's this idea, sort of like a use it or lose it, that to stave off dementia and neurodegeneration, you want to exercise the brain. You want to engage in crossword puzzles and these sorts of things. But nicotinic receptor activation might also be sort of tickling the cognitive pathways in the brain. And one, bit of evidence for this is that, patients that have impaired cognition, especially in schizophrenia, find great relief from smoking cigarettes. Similarly, if you are a baseball player, you might chew tobacco to increase your ability to attend to this baseball. There are many cases in which people have anecdotally used nicotinic agonists to enhance their cognition. So maybe smoking cigarettes or using tobacco in another way other than smoking cigarettes or using direct nicotinic pharmacology might tap into the same pathways of the brain that you're trying to exercise when you're doing a crossword puzzle. And maybe this could be combined with mental exercises, or if you are a lazy American, could be used in replacement of it. Not ideal, but this is an idea that has been in academia for quite some time. Parkinson's disease was first described in detail by James Parkinson in 1817 in an essay on the shaking palsy. Arvid Carlson in 1950 determined that dopamine was the neurotransmitter responsible and was exceptionally concentrated in the basal ganglia. I've seen Arvid speak. Interesting character. He is also the reason why in Europe they don't add fluoride to water. We do that in America because it prevents cavities. He was convinced that adding fluoride to water is going to lead to our downfall and lead to neuro disorders and everything else. I don't think the evidence supports that. And, I think that really the only thing that has come of that is they have more cavities and worse teeth. Carlson's research later showed that reserpine demonstrates a correlation between motor impairment and decreased dopamine levels. So what he did was he took bunnies and he gave them reserpine. Reserpine is a drug that depletes monoamines from all neurons. Basically, it results in monoamines like dopamine and noradrenaline being released from the neuron and ultimately being depleted in all of them. As a result, the bunnies stopped moving. Then he started adding back the monoamines one by one, actually with the idea that noradrenaline would be the most important in restoring the bunny's movement. Contrary to his prediction, noradrenaline had very little effect, but L-DOPA, the precursor to dopamine, when he gave that, resulted in the bunnies basically restoring their movement again. In California in 1980, a group of opiate addicts consumed MPTP, a toxic synthetic form of heroin, and that led to some patients, it took a lot of it, developing Parkinson's disease overnight. And, again, it's probably just a coincidence, but it is very true that Michael J. Fox was filming movies in this period of time and was going to drug using parties. You know, in that study, so these patients that received the synthetic form of heroin that destroyed the dopamine neurons and woke up with Parkinson's disease overnight from this toxin that could be similar to environmental toxins, like from heavy metals and other things that could build up in our brains over time. But these sorts of things, these MPTP patients received the first stem cell implants to treat or to introduce new dopamine neurons. The overall longitudinal looking back on this now shows that that trial wasn't very effective. This is going to promote some sort of enthusiasm for that work. There were some glimmers of hope from it. It wasn't a complete failure, but it also wasn't as successful as this might imply.
I saw you on TV last night, Channel 4 or something, and you were talking about this Parkinson's-like condition, and I'm seeing a young woman in her home. And this young woman was in a psychiatric unit for 3 weeks with a diagnosis, I think, of hysteria, hysterical paralysis. But she said, she sounds just like what you described on TV last night. Do you think she could be another case? I said, well, did she use heroin? And the answer was yes. And we said, get her in. And we saw her that afternoon. That was our 5th case. And in some ways, this was the most tragic young woman. This was her first summer using drugs IV, and we all know kids experiment. She got this stuff, and she is probably the most affected.
This was Connie. And after Connie came still other cases, like Toby. By the end of July, there were a total of 7. How many other drug users out there on the California streets were at risk? California had always had more than its fair share of drug problems, but in recent years, police had come across a disturbing new trend.
What am I being arrested for? Selling fentanyl. Sell heroin. To who? Our agents. Man, that is wrong, brother.
Drugs were turning up on the street, packaged and sold as heroin that were not derived from the opium poppy nor from any other natural product. They came instead from underground laboratories. Here, entirely synthetic versions of hard drugs were made, some hundreds of times more powerful than heroin. And it was all quite legal. Since the drug's molecular structure was different from any outlawed drug, they could be made, sold, and used with impunity. They were to become known as designer drugs. The heroin that George and the others took was not real heroin, it was a synthetic designer imitation. But what exactly was it? Langston collected samples and sent them out to chemists all over California, like Stanford University's Ian Irwin, with a plea: find the guilty chemical. All substances have unique chemical fingerprints by which they can be identified. Using a mass spectrometer to analyze the compound, Irwin obtained the mystery substance's fingerprint. He then fed it into a computer in Washington where the fingerprints of many known chemical substances were stored. He was looking for a match. As expected, it wasn't heroin. But it didn't match with any of the 40,000 known chemicals on the computer. The compound was apparently completely unknown. While Langston and his team puzzled over the mystery designer drug, unknown to them, a local police investigation was closing in on a designer drug chemist. This man was the key to the operation. A suspicious list of chemicals fell into his possession. For the police, this was a big break, because in reality he was an undercover narcotics agent, better known today as Deputy Sheriff Dave Weidler.
48065, got it.
North 10, North 31, be advised the suspect is now...
Dave Weidler turned the list over to the county crime lab. What would a local resident want with such large quantities of chemicals? Forensic scientist Jim Norris had to decide one thing. Was this the basis of a designer drug operation? The key suspect was well known to them ever since a notorious incident in nearby Saratoga 18 months before, when his residence mysteriously caught fire. Police and fire officials discovered he'd been experimenting on a vast scale making designer narcotics, but they were powerless to arrest him. Now it seemed as if he might be at it again, and all Norris could do legally was stage a fire inspection, but the suspect was ready for them.
The owner of the laboratory, when confronted by the fire department, first said that he was attempting to make hand lotion and also attempting to make a new type of snow cone. The chemicals that had been purchased were not appropriate to make snow cones or hand lotion. Most of them were very poisonous, highly flammable, and also very expensive. He had spent nearly $10,000 to buy just the chemicals.
Then the police started to hear about the frozen addicts who were turning up at Dr. Langston's clinic at the Valley Medical Center. They wondered, could there be a connection?
We knew that Dr. Langston had seized some samples from patients who had been admitted. And we asked Valley Medical Center to give us those samples so that we might conduct a further legal investigation.
I got a call, started getting a call from police, different police groups, and one in particular was Jim Norris of the local narcotics agency. And I remember that conversation quite well because he said, Dr. Langston, we understand that you have some samples of this synthetic heroin. And I said, yes. And he said, well, you know, we'd really like some of that. We need some of that for analytic purposes in our lab. And I said, I was being very nice, and I said, well, I'd really like to loan you some, but, you know, we just have a very small amount left of what we think is the critical sample, so I'm afraid I can't do that. And I remember there was a pause on the phone, and Jim said, Doctor, you don't understand. Either you can give us the sample, or I'm coming over there with some of my men, and we're going to take a sample. At that point, I realized I better negotiate it. I think we wound up splitting it. The second thing I remember about that conversation, and to this day it amazes me, is when I said, do you have any idea who this fellow is making this stuff? And his remark, it was almost casual. He said, oh yeah, we know who this guy is. We've known about this guy for 2 years. He said he was associated with this house that mysteriously blew up in Saratoga. And I said, well, why isn't he behind bars? And he said, we can't touch him. And after he explained that to me, that was the first time I'd heard about designer drugs, these new synthetics that are altered so they're beyond the reach of the law. He said, our only hope is to get this guy on his income taxes, and I was just floored.
Norris couldn't identify the sample, nor could pharmacologist Gary Henderson, the inventor of the term designer drug. For years, Henderson had been warning of the terrifying potential of synthetic narcotics. Tiny design changes to...
We aren't going to watch all of that. You can follow the clip, but you know that just serves to give you an idea of you know what MPTP is, how we discovered that you know it can produce these symptoms of Parkinson's disease overnight. But then should also, you know, show you. But this is also, you know, led to the first group of patients that received the stem cells for dopamine neurons, grafts that would then go on to lead to new dopamine neurons in the substantia nigra pars compacta as a treatment approach. The effects were very mixed. I think that they showed that there's potential for such a thing to work better in the future. But it would be wrong to suggest that that actually was effective. In general, I would say the trial did not work. So we know that the dopamine secreting neurons of the nigrostriatal pathway from the substantia nigra pars compacta degenerate. And that is a leading factor of Parkinson's disease, like, exactly how, like the neurobiology of the breakdown of that extrapyramidal motor system. Because remember, the basal ganglia can feed into M1 of the primary motor cortex that can actually control skeletal muscles. So the extrapyramidal motor system, composed of the basal ganglia and cerebellum, sort of can tune that behavior. And with when you lose dopamine, you're taking out one key circuit in that basal ganglia, and the entire circuit is off kilter after that point. This was first clumping within, or alterations within the nigrostriatal pathway was first described by the German neuropathologist Friedrich Lewy. Lewy bodies are what he described, and there are many types of Lewy body dementia, with Parkinson's being one of them. You can have Lewy body dementia and not have Parkinson's disease. But Lewy bodies are basically accumulated proteins that form these clumps that have abnormal circular structure with a dense core consisting of alpha-synuclein protein is the primary protein that composes them. The inclusions are particularly numerous in the substantia nigra pars compacta. So here you can see the substantia nigra pars compacta in the midbrain of a control brain. This black pigment is very pronounced in the from melanin containing dopamine neurons. And you can see in a Parkinson's patient, this melanin is not very apparent and is just a way of visualizing the loss of the dopamine neurons. Alpha-synuclein is a protein that can accumulate and build up and form into these clumps. This can result from just misfolding and accumulation of the misfolded proteins. The misfolded proteins can have many impairments that can first directly influence dopamine neuron survival and can impact motor impairment directly in this way. In addition, alpha-synuclein can spread and lead to the formation of other Lewy bodies throughout the brain. You see accumulation and spread of these Lewy bodies, usually from the substantia nigra, where they would be most pronounced. The Lewy bodies sort of look like a nucleus in histological preparation or on a slide. If you look at a slide of Lewy bodies under the microscope, to an untrained eye, what they're going to look like is going to look just like you're looking at a cell. But instead of a cell with a healthy nucleus, what you're really looking at is a Lewy body that almost takes the place. You can think of it as sort of the Lewy bodies as taking the place of the nuclei, which is somewhat true, and I guess an easy way of thinking about it. And clearly, you could see why that would be a problem to the functioning of the cell. So this is not limited to the substantia nigra only, though. It's also found in the locus ceruleus, where noradrenaline neurons are highly pronounced. Motor nucleus of the vagus nerve, the hypothalamus, the nucleus basalis of Meinert, which is associated with the cholinergic system, and the nucleus acetylcholine. A lot of nicotinic neurons or receptors in there. the cerebral cortex, the olfactory bulb, and the autonomic nervous system. This is confined largely to neurons. Glial cells do not seem to be very affected at all by the Lewy bodies. So here you can see just 3 examples of Lewy bodies taken from 3 different regions of the brain. In each, what you can see is essentially what would look like a nucleus to you. I think if I just pulled this up in day 1 and said, what do you see here? You might say, oh, I see a cell with a nucleus. Except that nucleus has been replaced by this, sort of fake nucleus or a Lewy body, just a clump of misfolded protein. The substantia nigra is the major origin of the dopaminergic neurons that innervate the striatum. It is part of the extrapyramidal system, which processes information coming from the cortex to the striatum, returning back to the cortex through the thalamus. Really, this is all just part of a basal ganglia system that filters ultimately back into the motor cortex that would then control motor behavior. One major function of the striatum is the regulation of posture and muscle tone. It certainly is involved in that fine-tuned control. Here you can see a picture of both the 2 main dopamine pathways, one projecting from the substantia nigra, the other from the ventral tegmental area just below it. The ventral tegmental area is thought to be involved in more sort of goal-directed behavior, reward-seeking behavior. The substantia nigra is thought to be more involved in habitual motor behavior, the development of, if you were going to learn how to play a new piano piece, that would all be about the substantia nigra. Late in the 1950s, dopamine was discovered in the brain, and it was determined that the highest levels were in the striatum. In the 1960s, the levels of dopamine are severely reduced in the striatum in Parkinson's patients. So we discovered that that is true. Parkinson's disease patients, symptoms become manifest when about 50 to 60% of the dopamine-containing neurons in the substantia nigra are lost. This is important, and I think shows the power of the redundancy that's built into the brain. The brain is generally made to sustain concussions, to sustain cell loss, to withstand loss of large amounts of neurons. There's a lot of redundancy built in there. So you can lose 50 to 60, maybe I've heard as much as 80% of dopamine neurons before you even see symptoms begin to emerge, which also is a problem in terms of treatment, in that you might not even see it until that neurodegeneration is so far along that you can't do much about it. Here are just, some examples of, how this progression might occur, where you see the Lewy body formation develop and spread. This can occur along different time courses, depending on your genetic makeup, how many environmental toxins you've been exposed to, these sorts of things. Familial Parkinson's disease, is thought to be associated with a few different genetic mutations. One is involved in encoding alpha-synuclein. You also have sporadic forms of Parkinson's disease where these aren't associated with any known genetic material whatsoever. Exposure to various insecticides, herbicides, and various drugs might play a role. Again, smoking cigarettes, has been shown to protect against Parkinson's disease. There is, of course, that, when you take into account that age is your greatest variable, there is a confounding variable there. However, even in age-controlled studies, if you smoke cigarettes, there might be something to this idea of nicotinic pharmacology staving off neurodegeneration in sort of a use it or lose it type way. That it would be sort of like a cheat, a lazy man's way of doing a crossword puzzle. You're stimulating the same neural pathways. The nucleus basalis of minor, which might be one of the first dominoes to go in neurodegeneration pathways. You're stimulating the nucleus basalis of minor, this cholinergic pathways, and the signaling cascades that could follow that might be very important for cognition. There are genetics that play a role. Most cases do not appear to have an origin, though. I mean, like the majority are sporadic. And even in the cases that do seem to play, genetics do play a role, most likely it is in interaction with the environment as well. You know, and then how this occurs is complicated. There is likely both gain of function and loss of function. And by that, I mean that in the case of alpha synuclein, it's possible that the increased prevalence of alpha synuclein and the Lewy bodies leads to some new function that isn't already or isn't there to begin with. This could lead to increased microglia activation, for example, and loss of healthy neurons in this way. Alternatively, you can have loss of function. One example here involves the gene Parkin. It's supposed to play a role in the ferrying away of defective proteins from the cell. It tags them with ubiquitin for destruction. However, defective Parkin prevents these from being tagged and destroyed, so you can lead with accumulation of bad proteins. Here's just a cartoon showing how dopamine synthesis occurs. Tyrosine leads to dopa, which leads to dopamine. Tyrosine is an amino acid. It and L-dopa can both pass the blood-brain barrier. Dopamine cannot. So if we gave a patient dopamine, it wouldn't influence dopamine levels in the brain, unless we were infusing it into the brain. But we can give tyrosine or L-dopa to increase dopamine levels, with L-dopa being the most efficient. In the 1950s, we first found that L-dopa can restore dopamine levels and motor function. Again, this was demonstrated by Arvid Carlsson, who won the Nobel Prize for this work. I've seen him speak. I've seen him present these data. They're pretty classic at this point in time, all done in bunnies. I've already described the experiments. Happy to tell you more about it, though, if you want to send me some questions. But, we now know that L-dopa can be used to treat Parkinson's treatments because it passes the blood-brain barrier and can lead to dopamine levels being restored. Here is just a cartoon of how this is happening. L-dopa passes through the blood into the brain to lead to increased dopamine levels. The efficacy tends to decrease as the disease progresses, and chronic treatment with L-dopa can lead to many adverse side effects. Gambling is a problem. Some people, again, think of the basal ganglia being very important in developing habits. So when you start, mucking around with this a little bit, you can develop some odd bad habits that can be hard on your family. So that's something to be aware of. This does not prevent the continuous degeneration of the nerve cells in the substantia nigra. It's therefore symptomatic. It's not really treating the cause, we're treating a symptom. Really, the same is true of deep brain stimulation. You're also treating a symptom, but it's also quite effective. Deep brain stimulation involves really the addition of constant stimulation to a region of the basal ganglia. This is subthalamic nucleus, which is downstream of the dopamine neurons, is most commonly targeted The external segment of the globus pallidus can also be targeted. Either one can be done without producing many negative side effects like you do when you directly stimulate the dopamine neurons. For those reasons, the subthalamic nucleus or the globus pallidus, the external segment, are what's typically targeted. And at least I had to study a surgeon that did these while studying clinical neuroscience during my PhD, and at least the surgeon that I shadowed targeted the subthalamic nucleus. It's debated and unclear what exactly deep brain stimulation is doing. The assumption that most people make when they hear about it is that you're stimulating the neurons to increase activity. That is the opposite of what seems to be happening. Either you are sort of shutting down the region by presenting a lot of stimulation to sort of like freeze it, or maybe you are even over time destroying the region, sort of like an electrolytic lesion. I think that the latter, that you're actually destroying the lesion, is what happens over time. And maybe early on, you're sort of freezing or shutting down the region with that electrical stimulation. But that's probably more what's happening during deep brain stimulation than actually exciting the neurons in a functional way. This involves a thin electrode that's implanted into the brain, targeting specific regions of the basal ganglia. Small electrical pulses are emitted, similar to a cardiac pacemaker. These can be tuned and altered by the patient. The mechanisms by which it works are not completely understood, but it seems to counteract the abnormal neural functioning that occurs from the loss of dopamine. Here is a quick video of a patient activating it.
Okay, so we're here for the initial programming session. You got both sides of the brain put in, bilateral stimulators, and we're here for the initial programming session. This is what it looks like without the medicine and the stimulator. And now we're just going to turn it on. If I can get my fat fingers to hit the button, there we go. See how that feels. How you feel?
I feel a lot better.
Yeah. Excellent. Try tapping both your fingers for me. Excellent.
Yeah, one of my favorite uncles had one of those. He loved to entertain the kids with it. He was a fantastic sport, and yeah, it probably did a lot to inspire my interest in the whole thing, honestly. But there are also stem cell transplants. I've already alluded to this a little bit. The first dopamine stem cells were given to the patients that suffered from the MPTP synthetic heroin, destroying the dopamine neurons. And you can watch their documentaries about how successful that study was. The reality is it wasn't all that successful. People didn't drop dead, so it proved it was feasible. But to say that those people were fine again would be wrong. That wasn't the outcome. Some were a little better than others. That's the reality. So 6 patients underwent the graft. 4 with advanced idiopathic Parkinson's, and 2 with that resulted from the MPTP. And as you can see, the initial results were quite positive. That you could see increased function in dopaminergic systems, but in general, I don't think that they showed much more than this can be done safely, and there's a lot more to it. especially when we're talking about full-blown circuits. And, once a full-blown circuit's off, every single domino along that path is off. So, I mean, especially if you're coming in after the entire circuit has been altered, you have to sort of limit your expectations of what can be achieved. Another interesting thing about Parkinson's disease is you start to lose your sense of smell early on. So, this also could be a benefit here. Maybe this is a way that we could get in and start trying to intervene before we've lost the majority of the dopamine neurons and we've had, other circuits start to change as well. So while most people with a reduced sense of smell will not develop Parkinson's disease, if this is starting to come about, at the very least, it might be something to be on one's radar. Some research suggests that the disease may start not in the substantia nigra, but in the gastrointestinal system and in the olfactory bulb. Researchers have hypothesized that alpha-synuclein clumps found in all people with Parkinson's may form in these parts of the body first before migrating to other parts of the brain. Especially the GI system part is pretty speculative and not something I accept myself. But, that speculation is out there. The olfactory part is very interesting. So here is one idea that, you might have the olfactory bulb accumulation develop and then migrate to regions where you also begin to see increased symptoms like sleep and motor disturbances, and then further migration that bring out emotional and cognitive disturbances as well. There are also vaccines that have been developed. There are also vaccines that have been developed against heroin, I might add. Something else we'll talk about a little bit. Not really so much about the vaccine, but we have vaccines for just about everything now. We can give you a vaccine that will go after alpha-synuclein, that will go after accumulation of alpha-synuclein. We also have vaccines that will train your immune system to attack heroin or fentanyl in the body so that it will not enter into the brain. The ethics of that are debatable. The ethics of using these alpha-synuclein ones are also debatable. Proteins have lots of effects throughout the body. We are at this sort of interesting phase now where we have these vaccines, and when and under what circumstances do we start giving them to people? Is something that I think we have already started to debate, and is certainly a subject that is worthy of continued debate. But now we're moving into Alzheimer's disease a little bit. Alzheimer's is one of these things that is going to affect many of us as we are an aging population. Alzheimer's is a chronic neurological condition associated with progressive loss of neurons. And really, there are many neurodegenerative disorders. Alzheimer's is just one example of many. And dementia is a broader term as well. Really, you can't diagnose Alzheimer's until you have that autopsy. I mean, how do you even know that someone has Alzheimer's rather than general dementia? General dementia can be defined as a loss of cognitive abilities such as memory, perception, verbal ability, and judgment. Common causes are multiple strokes and Alzheimer's disease. Many famous people have had Alzheimer's disease, including Charlton Heston, Ronald Reagan, and Norman Rockwell. In fact, his paintings are now used in dementia therapy because of the memories and nostalgia that they can elicit. Alzheimer first described the disease after finding altered proteins in the brain of one of his patients, Auguste Deter. Alzheimer's is a degenerative brain disease of unknown origin. It causes progressive memory loss, motor deficits, and eventual death. It is the most common dementia, accounting for about 50 to 50% of dementia forms. And it has vascular and misvascular and Alzheimer's disease being less common. The onset is in the 50s or 60s with gradual deterioration over 5 to 10 years, eventually leading to death. The average survival rate is 8 to 10 years with a general range of 1 to 20. The number of people that have Alzheimer's at any point in time is projected to increase with our aging population. Whereas, right, it will become just more and more of something that we live with in society and have to deal with. So, right, this is from a movie, but sort of a depiction of what Alzheimer's can look like, giving a face to it.
Jesus loves me, this I know, for the Bible tells me so. Little ones to him belong. They are weak, but he is strong. I get my hair done on Saturday. Is today Saturday?
Today's Saturday. It looks like you've already had your hair done.
I didn't.
You didn't? Do you have it done first thing in the morning?
I don't know. When did I get my hair done already? He put a thumb up, and
what
I don't know.
What does that mean? Does that mean yes or no?
I don't know.
Can you sing? Can you sing, Jesus loves me, this I know, for the Bible tells me so. Little ones to him belong. They are weak, but he is
strong.
You've got it. Thank you, Grace. Little ones to him belong. They are weak, but he is strong.
Yeah, just it helps, I think, to have a face to these conditions as well. So many of us probably have a face already of someone that's had to deal with dementia, and if not, most likely you will. And it is very difficult, and it takes a full community to help deal with this issue. Affected brain regions include the hippocampus, the entorhinal cortex, the neocortex, the nucleus basalis of Maynard, the locus coeruleus, and the raphe nuclei. In particular, there is marked deterioration of the neocortex. The sulci, or grooves, of the temporal and parietal lobe, shown here below, are widened in Alzheimer's, which is really just a way of saying that the surface area of the brain is deteriorating. There's just less brain. And the same with the ventricles being enlarged. Again, it's not so much that the holes are getting bigger, it's that the cells surrounding the holes are going away. So here you can see just a cartoon of the enlarging of the ventricles, which is really the loss of the cells surrounding them. Here you can see an imaging study showing that there's just less neural activity and less neurons to be recruited in a patient with Alzheimer's disease in comparison to someone with mild cognitive impairment, or especially to a baseline control. The neuropathology of Alzheimer's disease is most associated with plaques and tangles. Now, we now also realize that plaques and tangles are probably not really the cause of Alzheimer's disease. The reason that I say that, and which might actually contradict your book a little bit, is that we just went through this very large clinical trial in which a drug that can destroy plaques and tangles was, this has been proved to destroy plaques and tangles in a variety of preclinical animal models. So this was given to Alzheimer's patients in one of the biggest, most expensive clinical trials ever conducted in the United States. It involved multiple parts of big pharma. And It was a failure. This drug that we know destroys plaques and tangles failed to treat Alzheimer's disease. And so that's the science. There's a lot to say about this because right now the FDA, is they're in a tough spot. They have temporarily approved this drug for Alzheimer's anyway, even though it doesn't really work because, well, there isn't really a better alternative because none of the drugs for it work all that well. So it's sort of like, well, why not? We know that it destroys plaques and tangles. It just sort of failed to improve Alzheimer's outcomes. So what does that tell you? Like, like at the end of the day, what that tells me is that plaques and tangles might be a bit of an epiphenomenon. Maybe they're like scars. Maybe they're not really getting at the cause of the disease. That's a little different than what I was trained to believe. But all I know is that as a scientist, we have to follow the data. And the data show me that this drug that destroyed plaques and tangles didn't treat Alzheimer's disease. So, regardless, I am going to tell you about plaques and tangles anyway and what they are. So, plaques are formed by beta amyloid accumulation in the brain. Beta amyloid is a protein found in excessive amounts in the brains of patients with Alzheimer's disease. And a plaque is a deposit of beta amyloid protein that's surrounding the degenerated axons and dendrites. So you see these plaques build up outside of the neurons and then tangles build up inside of them. Here are your tangles. You can see these building up inside of the neuron, and these can actually break down the cyto infrastructure of the microtubules that are so important for the axon to function. The twisted protein filaments inside are called tau proteins. With Alzheimer's disease, the molecular structure of tau is changed and then causes other cells to die by interrupting the transformation flow of nutrients and other supplies. So, I was taught way back when that these plaques and tangles, their accumulation is the cause of Alzheimer's disease. And if we could break them down, prevent that from happening, get rid of them, we would cure Alzheimer's disease. The problem is that is not what happened. Look it up, Google it. Alzheimer's clinical trial, plaques and tangles. Really, this failure destroyed R&D in big pharma. I'm still sort of stunned and in a bit of shock by this. As a scientist, I actually always sort of thought I might end up as an R&D guy in big pharma. But for the most part, neuroscience R&D has been completely shut down because this Alzheimer's drug failed that badly. It, for the most part, doesn't exist anymore. It's all like, it's a game changer. Like, I cannot overemphasize how big of a fail this was. And I'm somewhat at a loss here. Like how can I tell you like that all plaques and tangles are the cause of Alzheimer's disease when we have this drug that gets rid of them and it doesn't treat Alzheimer's disease? But that's where I am right now. So that's just the way I'm going to teach that. We also know that Alzheimer's can develop along a longitudinal trajectory, and it also develops at different rates in different people. And this is something that maybe we can exploit in treatment further down the line. If we're waiting until the neurodegeneration has already occurred, there's probably very little you can do about it. there might be things that you can do to stave this off. First is early onset or early diagnosis, and then engagement seems to play a role. You know, smoking cigarettes is one way to go. There is some truth to this idea that nicotinic stimulation of, in particular, the nucleus basalis of Meinert, you know, could be an early domino that can slow the progression of Alzheimer's disease. You could do this in ways that do not involve smoking cigarettes. There are other ways you could stimulate similar neural pathways without taking drugs. These might involve doing crossword puzzles, doing Sudoku, these sorts of things. Highly recommend that. There is quite a bit of evidence to suggest that can reduce the speed at which degeneration occurs. Basically, the worst thing you can do is shut yourself off from society, and yeah, just basically accept it. ApoE is the one gene that is worth discussing. I am going to bring up one more because it's not all ApoE. It's not just one genetic risk factor, but ApoE is certainly a genetic risk factor. This is a glycoprotein that transports cholesterol in the blood and plays a role in the cellular repair. Presence of the E4 allele of the ApoE gene increases the risk of late onset Alzheimer's disease. Presence of an E2 allele on the ApoE gene might be protective. There's also the CD33 gene that has been implemented. Here in a recent study, they identified the CD33 gene as a risk factor. Particularly, it might be involved in the expression of microglia that can go on and then lead to neurodegeneration and cell death. You know, and the reason I want to bring in CD33 too is just because I think some people get the idea that, you know, there's this one gene ApoE, and that's not true. There's not just a one genetic risk factor. There are probably quite a few genetic risk factors. And just like Parkinson's disease, just like any of these neurodegenerative diseases, your genetic risk factor, you know, while it is a thing, you know, it can be turned on or suppressed by, you know, environmental and behavioral decisions and just factors in your life. My favorite theory right now in Alzheimer's disease involves mitochondria dysfunction. And I think personally that mitochondria malfunction is a common early denominator for all neurodegenerative diseases. It isn't just Alzheimer's. It isn't just Parkinson's disease. You also see the same thing in concussions, you know, in athletic-induced dementia, you know, where you have, you know, traumatic brain injury occurring from concussions or even a car accident or an explosion in the battlefield if you are a veteran. In all of these cases, one of the things that occurs is that the mitochondria in the cell don't work as well anymore. So whether or not you know, you've been exposed to that toxic metal, or you were just blown up, or you know, had a bad impact, one thing that can happen is that your energy production center in your brain breaks. And you know, just think about how important energy is in terms of everything you do, in terms of your society. You know, when energy breaks down, you know, society breaks down. You don't go to work, you don't get paid, war breaks out when energy goes wonky. You know, energy is so important for your brain to function. Your brain uses 20% of the energy, of the potential energy that you consume in a day. If your brain loses the ability to harness that energy, bad things are going to happen. And across the board, I think what will happen is degeneration. So if you were looking for the first domino that I think falls in the case of all neurodegenerative diseases, your professor's opinion is that is mitochondrial dysfunction. Now, how do you treat that? I don't know. It is interesting to know that mitochondria actually express cannabinoid receptors, and cannabinoids are lipid compounds that can enter into the cell. That doesn't mean I necessarily think that smoking cannabis can stave these things off, but cannabis is something that could be one of many factors that could influence mitochondrial function, in the case of neural insult. We need to know a lot more about how we can protect mitochondria, but I do think that this very important organelle, if we lose those, that could be a very first domino that goes down and leads to a cascade of events leading to lots of different types of neurodegeneration. We've already talked a little bit about acetylcholine deficits in Alzheimer's disease. One of the first things to go in Alzheimer's disease is something known as the nucleus basalis of Meinert. This, is a nucleus of the cholinergic system. And the nucleus basalis of Meinert degenerates early on, and I think that you have broken mitochondria in this region early on, and that is one of the first dominoes to fall in Alzheimer's disease. Cholinergic pharmacologies have been developed, including nicotinic agonists, to take the place of smoking cigarettes, to stave off the progression of Alzheimer's disease. To be honest, these drugs don't work all that well. They don't seem to hurt things, but they're not exactly producing these miraculous changes. I do think that they do improve cognitive performance a little bit. So you're going to improve symptoms, even if you are not getting at the cause. But yeah. And then again, we also have vaccines being developed, including a vaccine against beta amyloid. We have many vaccines that have been developed now that can attack plaques, that can attack tangles. We even have ones that can attack heroin. When does it become ethical to give these? Again, these have worked very well in amazing studies, in animal studies. We now have vaccines and drugs that can attack plaques and tangles and get rid of them. Unfortunately, these have not translated well from the animal literature to the human literature. I highly suggest that you Google this Alzheimer's drug failure. I mean, it just rocked my world. There really isn't an R&D sector in big pharma anymore that would employ me. So even if I wanted to leave academia for the for the private sector, the job that I thought that I would have doesn't exist anymore because this Alzheimer's drug busted that bad. So it was a game changer, and I don't really think we have a great treatment for Alzheimer's disease. And quite frankly, I think the FDA just approved a drug for Alzheimer's disease. It doesn't work for all the wrong reasons, because big pharma pressured them into it. Because I mean, like, I don't know, what else are we going to do? But that's sort of the state of Alzheimer's research right now, and I don't know. That's where I am. I was taught that plaques and tangles cause Alzheimer's disease. We got rid of them. Alzheimer's disease didn't go away. I think mitochondria are a pretty important variable early on, but I don't really have a great solution for how to fix broken mitochondria. So, right, that is the state of affairs. I think that there are various behavioral strategies that you can take if you start, or you or a loved one start showing signs of dementia. The use it or lose it thing, I am a strong personal believer in. This involves just being healthy. I mean, like engaging the brain, doing Sudoku, and it doesn't have to be Sudoku. Maybe Sudoku and crosswords are boring to you. Going and learning a new dance, going and learning a new piano piece, learning a new sport. There are many ways to engage the brain, but don't just sit on the couch all day degenerating. That's the worst thing you could do. That's all I have for Parkinson's and Alzheimer's. There are going to be a few more of these coming down the line.